The purpose of this presentation is to present John Macken's oscillating spacetime and his spacetime transformation model, which includes quantum gravity and could be the theory of everything. In simple terms as I could come up with. Many of the images in this paper are my interpretation and understanding of John Macken's model. If you'd like to verify the physics and equations supporting this model, please refer to the references at the end of the paper. The space-time transformation model overview. Is the room getting bigger or am I getting smaller? This is a quote from Alice in Wonderland. John proposes a unified theory of physics based on the assumption that the universe is composed solely of four-dimensional space-time, length, width, height, and time, with all matter, energy, forces, and fields being manifestations of its properties. His theory aims to bridge gaps between general relativity and quantum mechanics, emphasizing the significance of vacuum energy he calls oscillating space-time and understanding the fundamental nature of the universe. It integrates quantum mechanics and general relativity, offering a conceptually understandable framework for the theory of everything. This model proposes a new paradigm shift in cosmology, where the universe is not actually expanding, but appears to be expanding due to an ever-increasing background gravitational gamma that exists throughout the whole universe. John says with this background gravitational gamma, there is no need for the mysterious dark energy as required in the Big Bang model, where the cosmological redshift has been interpreted to mean that the universe is expanding and continuously creating new space. What we perceive as an increase in the scale of the universe is actually due to an increase in the background gravitational gamma of the universe, contracting the spatial and slowing the temporal dimensions of space-time. This is a change in the properties of space-time that has an effect on everything in the universe. In keeping with the laws of physics, as the background gravitational gamma increases, would in part result in the following. The rate of time decreases, the three spatial dimensions contracts, the energy of matter or particles decreases, and the speed of light decreases. John proposes that with the universe not expanding, all of the energy density was present at the beginning he calls the Planck space-time sphere and has remained constant throughout the life of our universe. This model also proposes a single quantum vacuum energy field called oscillating spacetime that allows the wave-based model of elementary particles such as fermions and bosons, along with gravity field, electric, and magnetic fields to exist. What is interpreted as 17 different particle fields in current quantum theories are actually the 17 particles finding their stabilized resonance frequencies in the oscillating spacetime medium. The more stabilized resonance frequency in the oscillating spacetime medium, the longer mean lifetime of the particle. Elementary particles in this model are suggested to be rotating dipole waves in oscillating spacetime medium called soliton waves. John proposes a model of quantum gravity, which is the biggest issue between general relativity and quantum mechanics. Gravity, as defined in this model, slows the rate of time, in addition to contracting the lengths of all three spatial dimensions, the length, width, height, and also affects many other forces, including reducing particle energy. It is proposed that all the observable energy lost by photons, neutrinos, and other relativistic particles are losing substantial amounts of observable kinetic energy. This lost energy is being converted to oscillating spacetime, which is vacuum energy, that does not possess angular momentum. Today, almost all of the energy of the universe has now transformed into oscillating spacetime. The general relativity model only recognizes a small portion of the energy in the universe, which are fermions and bosons, and believes that vacuum has zero energy. 9 basic key assumptions of his model consist of 1, the universe is only space-time, 4 dimensions. If this simple starting assumption is correct, it should be possible to invent a model of a universe that uses only the properties of 4-dimensional space-time. Ultimately, all matter, energy, forces, fields, and laws of physics should logically be obtained from just 4-dimensional space-time. Number two, oscillating spacetime energy is filled with vacuum fluctuations, stabilizing particles and forces. It is a nonlinear medium for dipole waves in spacetime. This nonlinearity ultimately produces gravity. And three, the soliton waves are fundamental particles modeled as rotating dipole waves in oscillating spacetime, explaining their energy, angular momentum, and inertia. They're proposed as the building blocks of particles and forces that modulate both the rate of time and proper volume. Number four, all forces, gravitational, electromagnetic, strong, and weak, are manifestations of a single relativistic force. Number five, gravity is derived from spacetime's nonlinearity, while electromagnetic radiation is explained as waves propagating in spacetime. Number six, the universe's expansion is attributed to space-time transformations, eliminating the need for dark energy. Cosmic redshift is explained by changes in space-time properties. Number seven, it provides explanations for phenomena like wave-particle duality, inertia, angular momentum, and gravitational attraction. Number eight, eliminates the need for virtual particles like photons or gluons. And number nine, it speculates on the cyclical rebirth of the universe, potentially returning to a state resembling space-time. Space-time transformation begins. The space-time transformation model proposes that at the beginning, the Big Bang, was a Planck space-time sphere that contained all the energy required to form our universe, about 1 billion joules. This sphere consisted of a plasma of 100% distortion-free photons in maximum confinement, which were observable quantized waves at Planck frequency and Planck energy density. At this instant, there was no pre-existing oscillating space-time or particles, matter, gravitational effects, and time did not exist. As these photons began to interact with the edge of the Planck spacetime sphere, this created a nonlinearity of the photons that distorted into three component parts. First component part is oscillating spacetime. This is a high-frequency, zero-point energy oscillating component that lacks angular momentum. These spatial and temporal oscillations in spacetime become the single field medium that allows waves and forces to form that generates everything in the universe. This single field propagates waves at the speed of light for all particles and forces. The next one is wave-based particles, solitons, and forces. These are fermions and bosons. This is a distortion-free component of the original photon waves in spacetime that retain the original quantized angular momentum, spin. This becomes the source of everything in the universe that we can sense today, which is all the fermions and bosons. Note that it has been experimentally proven that two 511,000 electron volt photons can be converted to an electron-positron pair. And the third one is background gravitational gamma. This is a non-oscillating component that becomes a background gravitational gamma. This is gravitational force that is homogeneous throughout the universe. This begins at zero gravitational gamma and increases as the universe keeps transforming or getting older. With background gravitational gamma, there is no expansion of the universe. Let's take a closer look at these three components. We'll look at oscillating spacetime first. High-frequency oscillating component which lacks angular momentum becomes a vacuum fluctuations or oscillating spacetime in the universe. This vacuum energy has quantum fluctuation zero-point energy that imply that it has a tremendous energy density. It is made of undetectable waves in spacetime that lack quantized angular momentum, no spin, and not observable, and are homogeneous as quantum mechanics allows. This is a uniform background energy density called oscillating spacetime. Oscillating spacetime consists of oscillating Planck volumes, the three spatial dimensions, changing at Planck frequency, which time. This is how spacetime is interconnected. Oscillating spacetime is visualized as a quantum mechanical sonic medium. It's a wave propagating medium. made of Planck-length oscillations at Planck frequency. These oscillations impose a local rate of time and generate the constants like the speed of light, gravitational constant, and reduced Planck constant. It is suggested that oscillating spacetime serves as a fundamental field that creates and unifies everything in the universe. The various fields in quantum field theory are seen as lower frequency resonances of this oscillating spacetime. An electron is theorized to be a rotating dipole wave, a soliton wave, within the medium displaying wave-particle duality despite being essentially a quantized wave. This soliton wave can vary in size, appearing smaller than a proton during high-energy collisions or expanding to the volume of an atom's orbital wave function. Oscillation frequency measured locally, same gravitational field, always equals Planck frequency. Oscillating space-time is a single universal field that is responsible for all other fields. It does not possess angular momentum. Any angular momentum present in the midst of the sea of vacuum energy is isolated into units that possess quantized angular momentum, or soliton waves. These quantized angular momentum units would include our fundamental particles, each having different waveform frequencies. When we have frequencies in excess of 10 to the power of 20 hertz, then waves in space-time are capable of achieving the energy density of fundamental particles. When we permit the frequency to reach Planck frequency, which is 10 to the power of 43 hertz, we can achieve the Planck energy density required at the start of the Big Bang, or the Planck energy density. Characteristics of oscillating spacetime include curvature. Massive objects curve oscillating spacetime, altering the path of objects in light. This leads to gravitational lensing, where light bends around massive objects. This provides a quantum-based rationale for the curvature of spacetime, connecting general relativity with quantum mechanics. It also has elasticity. Oscillating spacetime is often likened to a rubber sheet that can stretch and bend. Its elasticity allows it to be influenced by energy and mass, causing it to warp and stretch in response to matter. This means it has the ability to absorb energy and return energy as a wave propagates through this medium. It has impedance. This impedance of spacetime is so large that even a small strain amplitude produces a very large intensity for a given frequency. This enormous impedance of spacetime can only be achieved if spacetime has a large energy density implied by zero-point energy. The quantum mechanical basis of spacetime is real. It's a nonlinear medium. Viewed as a nonlinear medium, meaning its properties change in the presence of energy and mass. This nonlinearity is responsible for the creation of particles and forces, including gravity, through the oscillations of spacetime. It has wave-particle duality. According to this concept, particles like electrons are not considered as tiny points, but rather as structures formed by waves resulting from oscillating spacetime oscillations. This perspective aids in clarifying complex quantum phenomena that are challenging to grasp using conventional particle frameworks. Now we'll look at particles and forces. The distortion-free component of the original waves in space-time that retain the original quantized angular momentum, or spin, is proposed to become the source of everything in the universe that we can sense today, all the fermions and bosons. But space-time transforming energy is being removed from these Planck space-time photons, causing the temperature to lower in the universe. This allowed conditions for other fundamental space-time resonance particles, soliton waves, be formed at lower frequencies and lower energies. By trial and error, relatively long-lived oscillating space-time resonances were found that both held quantized angular momentum and also are compatible with the properties of oscillating space-time. These space-time resonances are proposed to be the fundamental particles of all matter and forces. The stability of these particles depend on the existence of oscillating space-time. The proposed wave-based model of an electron, or soliton, can be broken into two parts. One, a core wave rotating at an electron's Compton frequency, which keeps 99% of the electron's energy. And two, the standing rotating waves that surround the core wave, which radiates less than 1% of the electron's energy. Let's look at the electron soliton core wave. The rotating electron core modulates or distorts space-time in four-dimensional three-dimensional volumetric Planck length modulation of space-time and also modulates the rate of time. This is accomplished where one portion of a lobe, called the spatial maximum load, expands proper volume and slows the rate of time relative to local flat space-time. The opposite load, the spatial minimum load, reduces the proper volume and increases the rate of time relative to local flat space-time. The difference in rate of time between these lobes creates a rate of time gradient strain within the electron core. This rate of time gradient produces acceleration, which is directly related to the electron creating gravity. By trial and error, relatively long-lived space-time resonances, the soliton waves were found that both held quantized angular momentum and also were compatible with the properties of oscillating space-time. These space-time resonances are proposed to be the fundamental particles of matter. The stability of these fundamental particle dipole waves depends on the existence of oscillating space-time field. For example, the estimated mean lifetime of an electron is around 66,000 iota years, which is at least 5 quintillion times the age of the universe. The muon has a measured mean lifetime of about 2.2 microseconds, and a Z boson mean lifetime is estimated to be about 10 to the minus 20, the power of the minus 26 seconds. The rotating electron core creates outward Archimedean spiral waves. It is postulated that oscillating space-time has high impedance that allows certain frequencies, particles like an electron, muon, and quarks, to reflect back over 99% of the outgoing energy in the form of reflected inward Archimedean waves. These waves decrease in amplitude the further they move away from the core, but never go to zero. The combined outward and inward waves create a rotating standing wave. The electron's cloud of standing waves extends indefinitely. The rotating electron standing waves creates both the electromagnetic and gravitational fields. The electromagnetic field waves are created by the primary distortion in oscillating space-time as a linear effect that scales with amplitude, and the gravitational field is created by a second-order distortion in oscillating space-time, which is a nonlinear effect that scales with amplitude squared. By representing electron gravitational electrostatic forces as distortions of soliton waves, the equations simplify, revealing the direct relationship between these forces. This electron model also creates de Broglie waves when the electron moves. This exhibits action at a distance without resorting to mysterious exchange particles. The de Broglie waves or matter waves refer to the properties of matter that vary in time or space while showing a wave-like behavior. And the third is background gravitational gamma. This non-oscillating component that results when the waves in spacetime are distorted by the nonlinearity of spacetime is responsible for the background gravitational gamma that is homogeneous throughout the universe. But let's first talk about the effects of gravity. Gravity, whether it is background gravitational gamma or gravity created by an electron, both slow the rate of time, being referred to gravitational time dilation. Gravity created by an electron has acceleration, meaning that the gravity effects get weaker the further away from the electron, while background gravitational gamma is the same everywhere. Now, what may not be as obvious is in keeping with the laws of physics, a slower rate of time affects many measures and forces, including the following. 1. The speed of light slows down. 2. Our three spatial dimensions, length, width, height, contracts. 3. Proper volume increases. And 4. Energy decreases. With gravity affecting our local rate of time, it also affects our measuring instruments that have timing oscillators. This is how the speed of light always measures the same, which is constant, in different gravitational fields or potentials, as long as the measuring equipment is in the same gravitational field or potential as the light being measured. As the universe transforms, the background gravitational gamma is continuously increasing, which keeps slowing the rate of time homogeneously in our universe. with our three spatial dimensions, the length, width, and height, contracting due to an increasing background gravitational gamma, a meter stick is much shorter today than would have been at the time of the cosmic microwave background. So you could say we're shrinking. Thus, is the room getting bigger or am I getting smaller? Alice in Wonderland. There's ample evidence that general relativity works well by simply ignoring a changing background gravitational gamma of the universe. Effectively, current models are assigning zero to the background gravitational gamma of the universe and proportionally scaling from this assumption. Thus, the redshift observed today is being interpreted that the universe is expanding. The gravitational red-blue shift is often misinterpreted. Redshift is really caused by difference in rate of time. The internal energy of an atom changes with gravitational potential energy, but not only is there a change in the internal energy of an atom with the change of gravity, there's also a proportional change in the energy of an atom's electromagnetic and gravitational field levels when there is a gravitational change. Therefore, from the perspective of someone in zero gravity, a particular atomic transition in gravity is less energetic, and this transition emits a comparatively lower energy, lower frequency photon. This lower energy is not detectable locally because all energy comparisons have been similarly shifted to a lower energy by the gravitational effect on time and mass. This increasing gravitational gamma creates the same redshift that we observe today. The 15% photon energy at the cosmic microwave background, which was about 380,000 years from the Big Bang, has today been redshifted by a factor of about 1080. This has reduced the current energy content to an almost insignificant percentage of about 0.014% of the total energy in the universe. Similarly, neutrinos and other relativistic particles have also lost momentum kinetic energy due to this redshift. With the background gravitational gamma increasing the proper distance, the particle horizon increases even faster than the speed of light because our unit of length is also shrinking relative to coordinate length. The rate of time slows and proper volume increases. So, now is dark energy actually background gravitational gamma? The exact nature of dark energy remains a mystery. Nature of dark energy is more hypothetical than that of dark matter, and many things about it remain in the realm of speculation. Dark energy is thought to be very homogeneous and not dense, and is not known to interact through any of the fundamental forces other than gravity. Redshift that has been observed and interpreted as the universe is expanding has driven the need for dark energy. While both dark energy and background gravitational gamma are similar to the sense that both are proposed to be an energy force that is dominant and homogeneous throughout the universe, both have proposed to have varied their energy force throughout the age of the universe. They both appear to increase volume. Both create a similar redshift. However, there is nothing in the laws of physics to back up the force that makes up dark energy, while background gravitational gamma does follow the laws of physics. The current Big Bang theory claims the universe began out of nothing, which violates the first law of thermodynamics that says you can't create or destroy matter or energy. Space-time transformation model suggests that the universe started out as a Planck space-time sphere containing all of the energy required in the universe. So, what could the fate of the universe be? The angular momentum present today in the form of fermions and bosons was present at the Big Bang in the form of photons with the highest energy possible, which is Planck energy. Even though photons make up a small percentage of the energy in the universe today, photons of the cosmic microwave background still possess the vast majority of the quantized angular momentum in the universe. Space-time transformation model proposed here has not been developed sufficiently to have a clear prediction about the eventual fate of the universe. However, in the near term, like a few billion years from now, distant galaxies will get dimmer, but also the currently observed redshift of any particular distant galaxy will increase. This prediction is actually a continuum of the process that has occurred throughout the history of the universe. Over the longer term, the total energy density of the universe remains the same. Presently, observed energy represents only a small part of the total energy in the universe. We only can observe and interact with waves in spacetime that possess quantized angular momentum, fermions and bosons. This fraction of the total energy is dropping daily as the background gravitational gamma appears to be accelerating. If fundamental particles eventually decay into photons in the far distant future of the universe, an intriguing possibility exists. And quantized angular momentum of the photons become homogeneously distributed throughout the universe, then this condition of spacetime begins to look like Planck spacetime. The energy density is the same, and the average distribution of the quantized angular momentum is the same. The major difference is that Planck space-time had zero background gravitational gamma, and this final state of the universe has background gravitational gamma approaching infinity. Perhaps the energy in these photons becomes such a small fraction of the vacuum energy density of the universe that quantum mechanics allows the background gravitational gamma to round off to be infinity. The rate of time would stop, and the hybrid speed of light would stop. This is a discontinuity that would allow a rebirth of the universe. All has to happen is that the background gravitational gamma of the universe has to change from infinity to zero. No collapse is required because the universe is already at the required energy density. Also, the required quantized spin units would be preserved and evenly distributed. All that has to change is the rate of time, and the spatial characteristics must revert back to zero background gravitational gamma. This would produce Planck space-time, and the universe would start a new cycle with a new Big Bang. Could this be the recycling universe? And here are the references. So, John Macken's Oscillating Spacetime, the Foundation of the Universe, and his free book on the internet, called The Universe is Only Space-Time, Particles, Fields, and Forces Derived from Simplest Starting Assumption. This is where he has the space-time transformation model. And then a very good video, quantized wave model video by John Macken. There's a link below. So this is how I interpreted his models. So thank you very much.